So in the last class we saw an introduction onto calculus. Now let us look onto differentiation, a formal definition. Let us look onto the formal definition of differentiation. Now you remember this thing, which was shown in the first video or the second video, I don't remember. But you did see that in one of the videos. So, and I told you about finding the tangent of a curve. Now this is not exactly a tangent because this is not touching only one point, it is going through the line. But because I have to draw like this to make you see it. You get it? If I draw a tangent, this slope will be very small, and you remember you could not even see the slope when I did it in the last video. So it will be very small and I will not be able to show it. So therefore, to see it, I have made the line come a little bit here. Okay. So imagine it or assume it to be a tangent. Okay, for now, it is for you guys to understand. The same applies for the tangent also. Now there is two. So this is my distance axis, distance by time axis. We were studying about finding the speed or the velocity. So this is my I have this is my time. If I draw a line like this, I get the time, and I will call that time t. I will call that time t, and if I then I'm taking a little extra space called dt. I'm going a little extra dt, and then I'm finding a new time, that is t plus dt, to get a change in time. I mean, speed can only be found if there's a change in time, right? Only within a time period you can get a speed or velocity, right? So I'm adding a little I'm adding a small dt to the value t to get t plus dt. Now what is the distance? What is the distance? This is the distance. What is the distance at t? Distance at t I will get by doing the s of t. I mean, s is distance. I mean, I'm representing s as distance. And by the way, s is actually used to denote displacement in physics also. S is a standard. I mean, it's a common way of denoting displacement. Okay. By the way, so s of t gives me the distance at time t. S of t plus dt gives me the distance at time t plus dt. So this change in distance, so here if I am subtracting these two values, I get the change in distance, and I'll call the change in distance ds. So what all did I tell now? Ds is a change in distance, dt is a change in time. So ds by dt, okay, what is it? ds is the change in distances. So the s of t plus dt minus s of t, that is, you get the change in distance. Then dt is dt itself, t plus dt minus t is dt itself. So dt is exactly what we added, so that is the only change. Now to get the tangent of this, I told you this is not a tangent. To get the tangent, I have to make this dt smaller and smaller and smaller, right? So by getting the tangent, I actually get the precise, I mean very accurate values of the velocity or the speed. So limit dt goes to 0. So now it is perfect. Now this is the formula for differentiation. This is the general formula for this is not the general formula, this is the formula for differentiation in regard to distance and time graph. But this not only this not only can be used in distance and time, it can be used in any function. So I'm writing it like this: df by dx. df is f is a function, any function. I can differentiate it with respect to any variable dx, x or t or y or k or m or Vandana or Shruti or Kushi. You can use any name. Any variable could be anything. You could put any name in it. So I could take any function and differentiate it with respect to any variable. Here I am using x, and then this is the formula. So change in the function output divided by change in the input. Input is x, right? I mean, input is x. So because it is f of x, so the input is x. So change in the output by change in input but making sure the change in input is almost 0. Oh, I forgot the equal sign. Okay, so I think you get an idea of what differentiation is. We will solve few questions in the coming videos. So I wanted to make you, I want you to understand that this thing df by dx is how you represent differentiation, but it is a short form of this thing. This is actually the what differentiation is all about. This is the real formula for differentiation, but it is always difficult to write this every time, so we use a short form, and that short form is like this. Okay, so yeah, so differentiation is also, as I said, it is a slope of the tangent. You get the tangent, you get this line, red line becomes the tangent as dt approaches 0, and then you find the slope. This is actually how you find the slope also. Change in y divided by change in x, remember? So differentiation is actually the slope of the tangent, and this also you will understand in the more in the coming videos. So for now, I think you have understood enough about differentiation. In the basics about differentiation. Now the rest of the things, this is not just, there are more things that you need to study in calculus or in integration. There's something about integrations also, and then you will study more applications of differentiation in the next year in class 12th. And there are more interesting things coming up, and it is pretty interesting. If you can really understand what calculus is, it is really interesting. And don't listen when people say that calculus is really difficult. Yeah, people do say that, but it is a very interesting topic. And I'm not saying this to encourage your students, but I'm speaking it personally as a person who has studied calculus and who have worked on calculus. I can tell you that it is a very interesting thing. Okay, and it's very useful thing, and it is a very useful thing. Okay, but that could also be because I am interested in calculus, and so it's a topic that interests me a lot. And okay, before I stop the video, I want to show you something else also. Wait, I talked about slope of the tangent. Now look at this. This is a graph, a function, a blue line. You can see the blue line. So this is the graph of one function. It's an x cube function. Okay, it's an x cube. It's a cubic function. When you plot x cube, this is what you get. So the positive axis, you get like the first quadrant, you get like this, and then you get the graph goes like this. Now how to find the derivative? I told you derivative is done by finding the slope of the tangent. That is the slope of the tangent. So if I'm moving to do you see this you see the green line? The green line is a tangent. So as I'm moving this point, you can see that the tangent moves. So this is the moving tangent. So by finding out the slope, so I should find the slope at each and every point. After finding the slope, or basically that is differentiation. So by finding the slope of this, you can look at the slope. You can see the slope is really high here. The slope decreases, and it becomes 0 here. It's a horizontal line. Now there is no slope. Then the slope increases, and it goes to the maximum. Do you see? Now, so you understood how the slope goes. Now let me show you what is the differentiation of this graph. This is, you see the orange line? This is actually the difference. If I differentiate x cube, I get this function. I'm not telling you what it is because you won't understand it now, but so you can look that it is, see here the slope is 0, and that is why the orange line is also 0. Now as the slope increases, do you see the orange line going up? And as the slope here, the slope was increasing. So you see the orange line is going up. But by the way, when it comes to 0, the slope is becoming 0 because it is becoming the tangent is becoming a horizontal line. Do you get it? I know that you might not be able to understand everything what I'm showing here in this graph, but I think you might be able to get an idea of what is happening. So so that will be it for today. So we'll close for today. So thank you guys for listening. Bye bye.